With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a rod of mass m and length L is placed on a smooth horizontal surface. It is hinged at one end so that it can rotate freely in a horizontal circle about this end. There exists a uniform magnetic field B vector perpendicular into the horizontal surface everywhere. The strength of magnetic field starts varying as B equal to B naught T. Find the torque acting on the rod about its hinged end and find the reaction produced at hinge at t equal to 0. A charge q is distributed uniformly on the rod. Hence we can see here, suppose let's say this is the plane in which this rod of length given in the question as L is, let's say, rotating. So this is our, let's say, rod now hinged at the center of this ring here. So we can see this rod has mass m and we can say length is given as L and magnetic field is everywhere present everywhere here of magnitude given here as, let's say, B equal to B naught T. That is, magnetic field here is increasing with time. Now here we can see we need to find the torque acting on the rod about its hinged end. So about this hinged end we need to find the torque on this rod. So we can see here that the torque is, let's say, here given by, we have here as tau is equal to, we can say, as R cross F, where we can say this can be written here as, let's say, length L into, we can see this comes here as F is equal to lambda into E dot, we can see here as dl, since this has a charge q uniformly distributed on the rod as the question says. Now as we know, if, let's say, magnetic field varies with time, so there will be an induced electric field. So the induced electric field corresponding to varying magnetic field is given here as line integral of electric field is equal to, we can say, as minus of d pi by, we can say, as dt. So here we can see this magnetic flux is given here as b into pi into r square, where radius of this circle will be length of the rod. So this comes here as minus of b into pi l square. Now here pi l square is constant, so this comes outside, hence this becomes dv by dt. Now we can see here on differentiating b with respect to time, this comes as, let's say, b naught. So this here is pi l square into, we have here as b naught. So this value is our, let's say, line integral of E dot dl. We have here as pi l square b naught and lambda can be written as q by l, and this comes as L into, we have here as q by L into, this here is line integral of electric field, which we have calculated as, let's say, this as pi l square b. Hence substituting, we have here as q into pi l square into b naught. This is the torque acting on the rod about its hinged end. This is our first part answer. Now coming to the second part, the reaction produced at hinge at t equal to 0. Since at t equal to 0, we can see here that magnetic field is 0. That means magnetic flux at this instant will be 0. So we can see here this E dot dl value will be our 0. So this, let's say, b naught into, here we can see this whole part will be equal to 0. Hence there will be no reaction force at the hinge point. Hence the normal hinge reaction force at this point will be 0.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.